Okay, this is part 3. We're going to go ahead and finish off with 11, 12, and question 13. Question 11 is another percent composition. The compound is 39.0 grams of silver and 8.30 grams of sulfur. So in this case, what we need to do is go ahead and find ourselves a total mass, and we're going to divide the total mass by the part that is given to us. So when I add, let me go ahead and write this out. When I add 39.0 grams of Ag plus 8.30 grams of sulfur, my total mass is 47.3 grams. I'm going to write total. So now I'm going to take each part and divide it by the total, multiply by 100 to get a percentage. So let's do 39.0 grams of silver divided by 47.3 grams total. And I'm going to multiply by 100. My final answer there on that one, I'm going to get a percentage of 82.5% silver. Now you have two options, right? You have two compounds, and the percentages have to add up to 100. So at this point, technically, you could take 100 and subtract 82.5 in order to get sulfur. But I'm going to go ahead and work it out on the other side. That would be 8.30 grams of sulfur divided by 47.3 grams total. I'm going to multiply by 100 when I'm done. Final answer there is going to be 17.5% sulfur. So I'm going to go ahead and report my values over here. 82.5% silver and 17.5% sulfur. Number 12, determine the empirical and molecular formulas of a compound that is 40.0% carbon, 53.4% oxygen, and 6.6 hydrogen. The molar mass of the molecule is 121.2. So I got a two-part problem here. This will be the longest problem that you will see. The first part, we need to find the empirical formula. Second part, we'll need to find the molecular formula. So let's do number 1 first. Empirical formulas, I need to remember my poem. Percent to mass to moles, divide by smallest, round till whole. First step, I'm going to turn my percentages into masses. 40.0 grams of carbon, 53.4 grams of oxygen, and 6.6 grams of hydrogen. Percent to mass. Step 1 is complete. Now I need to do mass to moles. 12.0 grams of carbon for every 1 mole of carbon. 16.0 grams of oxygen for every 1 mole of oxygen. 1.0 grams of hydrogen for every 1 mole of hydrogen. Percent to mass, I'm still calculating mass to moles. I get 3.33 here. I get 3.34 here, and 6.6 here. So in this case, this is, these are moles of carbon, moles of oxygen, and moles of hydrogen. Percent to mass, mass to moles, divide by smallest. In this case, the smallest is going to be 3.33 moles of carbon. 3.33, 3.33. I'm going to get 1.00 here and 1.00 there, and this one's going to be 2.00 here. So when I round till whole, my final step, percent to mass, mass to moles, I just divided by smallest, and I'm going to round these numbers to whole, which would be 1, 1, and 2. So my empirical formula are going to be the subscripts of these numbers. So my empirical formula, I'm going to go ahead and fill it in here. My empirical formula is going to be COH2. COH2. And now I need to go ahead and find the molecular formula. So my equation for molecular formula is N equals GFM divided by the EFM. Well, the GFM is provided to me, 121.2 grams. And I need to divide it by the EFM, which I need to go ahead and solve. So I'm going to take my empirical formula that I just solved for, and I need to find the molar mass. Carbon, oxygen, hydrogen. 1, 1, 2. Molar mass, 12.0, 16.0, 1.0. That's going to be 12.0, 16.0, and hydrogen gives me 2.0. My molar mass of my empirical formula is going to give me 30.0 grams per mole. So I'm going to plug that in over here for the EFM, 30.0 grams.
Pardon interrupting your work time.
Sorry about that, little announcement here. And when I divide the two, my final answer for N, the multiplier for my molecular formula, I am actually going to get a value of 4.04, which I'm going to go ahead and use a whole number here, which would be 4. So this is my multiplier. So I'm going to take 4 and multiply it by COH2, my empirical formula. And that is going to give me C4O4H8. So my molecular formula is going to be C4O4H8. And last but not least is going to be question number 13. Compound contains 47.08% carbon, 6.59% hydrogen, 46.33% chlorine by mass. The molar mass is 153 grams per mole. What are the empirical and molecular formulas? So this is going to be identical to the problem above. We have two parts, empirical and molecular. 47.08 grams of carbon percent to mass, 6.59 grams of hydrogen, 46.33 grams of chlorine. Percent to mass, mass to moles, 12.0 grams of carbon for every 1 mole of carbon, 1.0 grams of hydrogen for every 1 mole of hydrogen, and 35.5 grams of chlorine for every 1 mole of chlorine. Percent to mass, mass to moles. Let's go ahead and calculate this guy. Answers, first part, it's going to be 3.923 moles. And then we have 6.59 moles of hydrogen. This is carbon, hydrogen. And last part, 1.301 moles of chlorine. Percent to mass, mass to moles. Let's divide by smallest. Let's not forget that step. Common mistake is we forget to divide by smallest. 1.301 is the smallest. So final answer we get there would be 1.000. This one we get 5.04, and up here we get 3.015. And we need to go ahead and round those to whole. First one we're going to round to 3, 5, and 1. So our empirical formula is going to be C3H5Cl. Part 2, I need to go ahead and use my molecular formula equation. N equals the GFM over the EFM. The GFM has been given in our problem as 153 grams per mole. So I need to find the empirical formula mass. I have carbon, hydrogen, chlorine. Got 3 carbons, 5 hydrogens, and 1 chlorine. Here are the molar masses. We have 36.0, this should just be 12.0, excuse me, 5.0, and 35.5. When we add those up, we get 76.5 grams per mole for the empirical formula. I'm going to plug it in up here, 76.5 grams per mole. And I am going to get a value of 2 for my multiplier. So I'm going to go ahead and scale up my empirical formula. 2 times C3H5Cl. And that's going to give me C6H10Cl2 for my molecular formula. C6H10Cl2. Okay, there you have it.